The coordinate plane was invented by René Descartes. Yes, the "I think, therefore I am" guy. Apparently, he was lying in bed watching a fly crawl across the ceiling and thought, what if I describe that fly's location with numbers? He realized he could describe the fly's position using its horizontal and vertical distance from the corner. And just like that, math got its first GPS system. So next time someone tells you daydreaming in bed is lazy, tell them you're doing Cartesian-level thinking. The 4 quadrants are labeled with Roman numerals, because apparently regular numbers just weren't dramatic enough. Good thing there are only 4. Can you imagine if we had 37 quadrants? You'd need a whole scroll to write XXVII. By the time you finish labeling the graph, the math test is over and you've developed carpal tunnel and a deep respect for Arabic numerals. How do you measure the distance between 2 points on the coordinate plane? You bring a ruler. Just kidding. This is algebra. We bring a formula. We treat the horizontal and vertical changes like the legs of a right triangle, then use the Pythagorean theorem to find the diagonal, the hypotenuse. What do you do if you wish to meet a friend who lives on the other side of the city? You meet halfway, maybe at a coffee shop, maybe at the midpoint between your x and y coordinates. That's all the midpoint formula does. It averages the x values, averages the y values, and gives you a fair meeting point. It's the perfect compromise. A graph is an exclusive private club of points on the coordinate plane. In the case of a circle, the rule is strict. Only points that are exactly a certain number of units away from the center get in. Too close? Rejected. Too far? Denied. It's the geometry version of a VIP guest list, and the bouncer is the distance formula. This is where algebra and geometry team up. One does the distances, the other turns them into useful numbers, like how many laps you'll need to run around a rectangular yard to burn off that donut you ate while pretending to study. Fun fact: triangles are the only polygon that can't be pushed around. Once you fix the lengths of their sides, their shape is locked. No drama, no deformation. Rectangles? Total pushovers. You can shove a rectangle and it'll collapse into a parallelogram faster than a group project falls apart. This is why engineers trust triangles. They're the most structurally stable geometric shapes. In geometry, triangles are supposed to be the most stable shapes, but love triangles? Not so much. Turns out emotional distance is harder to measure than Euclidean distance, and there's no formula for heartbreak. Unless, of course, you're Jean-Jacques Parabellow, who once tried solving his romantic life with substitution and elimination. It did not end well.